Physics. Now, physics is an awesome subject, and we're going to start that subject today. Now, I just did some optics. So, firstly, what are we going to cover in this video? We're basically going to cover all of this. I always use contents here. So, motions, forces, work, energy, and heat, and all this shebang stuff. So, let's get this started with. We only got 7 minutes, people. Well, sort of 7 minutes. I've already told you guys what physics is. Now oh my gosh, my hair. Now I'm going to tell you guys about motion. Now we all know about motion. It's the reason why this thing will roll, like roll. And it's the only reason why gravity exists. It's because of gravity that this thing also falls. And it's also why the famous apple tree experiment happened too. So the apple was not yellow. And Sir Isaac Newton, who lived particularly old for his time, 84 years old, that's pretty old for the time. It was basically said he created these 3 laws of motion, and he tried to make them overly complicated because he didn't want random everyday people to be able to understand. So Newton's first law basically says an object in motion will stay in motion unless an external force is acted upon it. The second law says that the force acts on an object, and the greater the force, and it's in this particular direction, the object will go in that direction compared to the proportionate to the force's amount of movement. And the third law of motion says every action has an equal and opposite reaction. And that's pretty much how everything seems to work out. And then forces will happen. Here are basically the general forces. Friction, gravity, magnetism. What is this? Applied force, buoyancy, tension, drag, and spring force. Yeah, that's all I'm going to say right now. Work, energy, and heat. Work, energy, and heat. This is one of the greatest achievements of human knowledge, because without knowing about what work, heat, and energy is, then you basically be a dumbhead. Work, not the kind of work that your dad goes to just so that he could get money. In this case, it means like a force times how much mass the object you're moving is. Work is basically moving an object so that the object moves, or it's doing something else. So you're basically a crewmate when you're working. And energy is how much input you're putting into your work so that you're putting enough mass towards it. And sometimes some of that energy is expelled out not as actual movement energy, but as friction. And that friction is basically what's happening and that friction is basically what's creating the heat. Like, when you rub your hands together and say clear, that's basically what friction is. That's why it's making heat. And you can even use steam-powered engines to make heat. In fact, that's how steam-powered engines work. Now, our next word is light and dark matter. I'll figure that out later. Light and dark matter is something that we all know. Light matter is basically the matter that we know. It's the kind of matter that I can touch. It's kind of matter where I can touch that little screen right there. It's the matter that's in this water bottle. Bottle flip. It didn't work. And that's pretty much it. Next thing would be dark matter. Dark matter is this part of 27% of the universe. We don't even know it's there. We can't even feel it, we can't even touch it, we can't even smell, we can't taste it, we can't even hear it. But we know it's there, because without it, the whole universe would probably be shrinking on itself. Because of dark matter, it's expanding. It's like Alien X. It's like Alien X trying to pull matter out. Yeah! For those of you who do not know who Alien X is, don't Google him up. It's not that. It's pretty cool. It's pretty cool, and I don't want to share this coolness. Yeah. Our next part would be electromagnetism. And you know what magnets are. It's the stuff that lets you put stuff on your refrigerators and let other magnets connect to each other, either here or apparently this spoon itself is a magnet. Oop, it falls pretty weak, so. And the thing is, the whole magnet idea is just basically a metal, mainly iron, cobalt, and nickel. There are no other metals that can do this except specific compounds of those metals that can have a magnetic field here that can connect to each other. Unfortunately, this will not happen because this will just repel each other. Let's assume this side is the south and this side is the north pole of each magnet. Then we do it here and they'll attract. But if I try to do this, I can feel some repulsion. Or if I want something easier to do, then I'll just grab the top of this and I can already feel some repulsion. See? And I'll try to get close. Yeah, it doesn't work. And eventually, if you put them together, in this case it's a weak magnetic field, so I can just put them together. I can't even leave it there. I can't even leave it there. Watch this. I won't stay there. That's how repulsion seems to work. They repel, opposites attract, and likes repel each other. It's like twin rivalries. Next thing, though, is that there are different forces in the universe, like this strong nuclear force, or the weak nuclear force, or the electromagnetic force, and other forces too. That seems to govern the ways it works. And if you use the strong nuclear force, then this thing would stay. It's basically like a glue that holds this together. But for now, I think I prefer to have this. Whee! Alright, on to the next topic. Experimental physics. Experimental physics is the physics that you do with your mind. It's like, if I turn this, if I throw this and then it somehow goes at the speed of light, what would happen to it? It would most likely dissolve, yes. But let's say it's anti-dissolvable, no matter how fast it's going. Then what would happen to it? Well, then it'll probably come back to me in a few seconds, wouldn't it? Because it'll go in orbit. It's going faster than the speed of light. It's going about as fast as the speed of light, which is nice. Our next word is theoretical physics. Now, this is more of the thought experiment stuff. And the thing about what I said about experimental physics, you're actually going to have to throw the spoon, but it's impossible right now. So right now, that would be theoretical physics. Until we find a way that we can actually do that, until then, we have to do theoretical physics. And theoretical physics is basically all those thought experiments where you're thinking, if I throw this up there, and then it turns into this, just because someone built it into some weird physics facts, then maybe, why does gravity sometimes not make it go down? In fact, my hand, sometimes it gets repelled from this thing. And we find out that's because everything's diamagnetic, including water. And now we're going to talk about physics and everyday life. Physics in a plane. How does a plane fly? Because, there's this thing where it's not, airplanes aren't less dense than air. Nothing is less dense than air other than other air. What it goes is, there's the engine inside, there's a compressor, and then it creates lift. And big lift is basically like wind that makes this thing go up. The air tries to push it down, but this lift here, it has more. However, the air right down there, on top of there, trying to push down, there's an equal amount of force onto it, so it stays up. And until the engine starts revving down, and then it becomes unequal, the plane starts going down. And this is bad if you're in the middle of your flight plan, and very bad, and pretty good when you're trying to land. And physics in a car. Physics in a car, the most common way you would die in a car is car crash. Second common way you can die in a car is someone trying to kill you in a car. Wow. Or in the middle. Or you're going to the hospital but you die while on the trip. That happens. And then the people start realizing and start talking about the cars in the front and the back collisions. And the seatbelt saves you because it tries to stay in the same place until an extra force is permitted to do. And the sudden stopping of the car tries to make you move forward while the seatbelt tries to make you go backwards. Meaning they try to cancel each other out. And since they almost cancel each other out, you stay there. And if the seatbelt breaks, there's an airbag that will just save you. Most of the time, so don't trust it too much. And that's it for today. I hope you guys enjoyed this episode of Hunter Sean, and I will have some fun with magnets. Magnets. If I do it this way, yes. If I do it that way, hey. Alright, bye guys. Whee!